Hello everyone, I wanted to welcome you to this short video workshop on how can we apply data science into the field of nautical archaeology. The purpose of this video is to introduce the topic to archaeologists and general public. As part of the ambassador program for the Texas A&M Institute for Data Science. Given the introductory nature of this video, we are going to discuss general topics and a basic procedure applied to archaeological data in order to obtain results relevant to social and human sciences. First of all, I would like to introduce myself very briefly. My name is Raul Palomino, and I am a PhD student in the Nautical Archaeology program at Texas A&M University. I am personally interested in the history and archaeology of Iberian seafaring and shipbuilding tradition from the 16th and the 17th centuries. This also includes the construction features and processes that characterize such tradition and how can we apply digital methodologies to record it and use that data for 3D reconstruction to perform hydrostatic analysis. And pursuing this interest, I had the opportunity to work in projects in Peru, Spain, and also here in the United States. The next thing I would like to introduce is the field of nautical archaeology. What exactly is it? Usually people understand archaeology as just the study of human past. It's not an incorrect assumption, but in that case, what is the difference from history then? History, by definition, is the study of society through past primary sources. This means the exclusive use of written documentation. On the other hand, archaeology mainly works with the physical evidence, material remains like tombs, architecture, artifacts, etc. Archaeologists, in some instances, we can use other sources of information, like written documentation as well, but our primary focus is the material evidence. Naturally, as every other discipline, there are subfields and specializations, like ancient archaeology, classics archaeology, geoarchaeology, etc. One of these subfields is the nautical one. By definition, nautical means of or concerning sailors or navigation. And this is the key difference, because nautical archaeology focuses on navigation or therefore vessels. Now, it is important to mention that this not necessarily equals submarine archaeology, since not all shipwrecks are underwater. They can overlap, but they are not the same discipline necessarily. The other part of this presentation focuses on data science. What exactly is that then? As it says in the slide, data science is the study of data to extract meaningful insight. Normally, data science involves different approaches such as mathematics, artificial intelligence, computer engineering, and of course, statistics. For the present study case, we are going to focus a little bit more on statistics since it's the methodology used for the course study. By definition, statistics is the practice or science of collecting and analyzing numerical data in large quantities to obtain answers for specific questions. For example, statistics is used heavily during election seasons. How do you think these questions can be answered? In what states such or such political party is more popular? What type of socioeconomic classes tend to vote more for a specific party? Or what age group does a party appeal so more to? Naturally, to obtain the raw data, surveys are usually used. But once we have this information, statistics allows to interpret it and analyze it. As a professor of mine would say, it is just an approximation of the truth. After explaining briefly what is archaeology, more precisely nautical archaeology and statistics, a new question arises. How can we apply statistics in archaeology and why? As I mentioned before, archaeology relies heavily on material evidence, and this evidence can be interpreted in several ways. One of them is through measurable variables. For example, imagine that you have a large amount of pottery fragments. By themselves, those shreds don't say much, right? But we might need to look at them through the right lens. We can describe each shred by the type and percentage presence of the components that make each piece. Another way to understand it is through the shape of or purpose. The fragments can belong to a ceremonial pot, can be separated from the ones that belong to everyday use jars, and analyzing the presence or amount of fragments like this, we can have a better idea of what type of activities took place in the space where they were recovered. We can apply the same concept and methodology to, for example, a pre-colonial cemetery. We can divide each funerary context through period, sex, age, pottery associated to the individual, etc. And therefore, we can have an insight of the space distribution or processes that took place there before. Most people may be unaware of this, but statistics have been more and more common in archaeology for the last decades. In good part, this is due to the contribution of processualist archaeology, a theoretical model that started back in the 1960s, thanks to the gentleman in this picture, Dr. Louis Pinford. Regarding the present study case, it aims to serve mostly as an example of how useful it is to apply statistics into nautical archaeology as well. Also, this is my ongoing doctoral dissertation in the anthropology department. With this research, I am looking forward to use statistical analysis on hydrostatic data obtained from digital reconstructions of Iberian shipwrecks. The goal for this research are, first, to use the results to determine the relationship between the standardization and agency of Iberian shipwrights while building these vessels. These concepts will be explained in further detail in the next slide. Moreover, the second main goal of the current project is to use this data and compare it with non-Iberian ships. Since the classic Iberian vessel, as we're going to see later, became very popular by mid-16th century, I am interested to see how different or similar were other traditions, such as the English one, in comparison to the galleons and carracks from Spain and Portugal. As I mentioned before, the agency of the Iberian shipwrecks is one of my goals for my current research. But what exactly is agency? According to the Merriam-Webster dictionary, agency is the capacity, condition, or state of acting or of exerting power. Another definition provided by the same source is a person or a thing through which power is exerted or an end is achieved. But for this particular case, I would like to use a definition more according to social and human sciences. The capacity of an individual to actively and independently choose and to affect change, free will, or self-determination. The concept of agency can have variations or specific meanings depending on the context, the theoretical paradigm, or just simply the researcher applying these concepts. For this reason, I was interested in showing a more general definition by the Open Education Sociology Dictionary, and simply puts the agency of a person is what allowed, simply put, the agency of a person is what allowed them to act different from the rule, the structure of a society. Just think about it this way. An artist having a particular style that goes against their time, like for example, Salvador Dali, who revolutionized art through his personal expression. In social sciences, this means that not all the people think the same way, and they can have their own input in their society. This can also be found on the archaeological record. For example, the ancient moche from Peru are widely known for their iconographic style that is easily recognizable. But if we put more attention into detail, we can see that the moche artists have stylistic differences, and we cannot say that there was only one moche artistic canon. Secondly, I am interested in determining how similar or different were the Iberian ships to those of the same period. For this comparison, the research aims to use two of the most known and better preserved cases, the Mary Rose and the Vasa. The Mary Rose was an English ship of the Tudor period that was highly regarded in the English kingdom due to its role in historical battles. However, the ship was lost in 1545 and eventually recovered in 1982. Being that it's one of the best preserved ships ever found in the archaeological record, the ship went through several processes of conservation to keep it to keep it as it was found, and it can be still seen in the museum located in Portsmouth. On the other hand, the Vasa faced a shorter history actually. It was a Swedish vessel that started the construction works on the second half of the 1620s, and it was finished by 1628. However, during its inaugural departure, the ship sank less than 2 kilometers after sailing from port. The reasons for its sinking are still sparking debate, but some people argue that it was because they decided to add an extra deck on the stern castle, and this affected the ship's initial stability. Whatever the reasons, the vessel remained as one of history's unluckiest maritime losses, but due to its extremely well-preserved hull, it was recovered in the decade of 1960s, and after 10 years of conservation works, it is open to the public. Before proceeding, I would like to briefly explain the historical background to contextualize the research. At the end of the 15th century, Europe, especially the Iberian nations, started a massive colonization process that lasted for centuries to come. As previously mentioned, the discovery and subsequent conquest of America was pivotal for the Spanish and Portugal nations, but the colonization of Africa and Southern Asia was equally important. As seen in the map, the treaties of Tordesillas and Zaragoza determine the areas in which both countries can expand. The orange regions show the territories that belong to Spain, while the blue ones to the Portuguese. The world power became even more centralized when in 1580, after the death of Henry I, Portugal was added to Spain since Philip II was a close relative of him, who died with no heir. In that moment, Spain became the most powerful nation in the world between 1580 and 1640. As expected, in order to sustain such intercontinental power, a maritime infrastructure was required, meaning harbors, routes, shipwrights, official agencies, but above all, as you can expect, ships. It is for this reason that the naval industry saw a peak that can be witnessed in the development of larger hulls. The first nationally funded armadas, standardization attempts by the Crown, the application of arithmetics, and the early beginnings of written documentation regarding shipbuilding. This nautical development was also possible thanks to the privileged position of the Iberian Peninsula. As seen in the map, this area works as a nexus point between two different naval traditions, the Northern European tradition and the Mediterranean tradition. The classic Iberian ship adopted the square sail and the flat stern with a central rudder from the north, but the Latin sail and the rounded stem from the Mediterranean. During this period, the most common ship designs were the carrack and the galleon. Usually the carrack, or now, was preferred by sailors for commercial purposes, while the galleon for warfare. Both vessels have very similar characteristics, rounded hulls with flat sterns, and the rigging composed of square sails on the main and foremast with Latin rig in the mizzenmast. Although the galleon could include a Bonaventure mast Latin rig as well. In terms of proportion, were also very similar. As seen on the diagram above, the keel was the central piece that determined the construction of the craft, and the overall length, as the name suggests, is the total extension of it. Here we can appreciate the keel, and here the overall length. Moreover, another important dimension is the maximum breadth, here seen in the screen. That means the maximum width of a ship. The carrack approximately had a keel twice the length of the maximum breadth, and an overall length 3 times the breadth. On the other hand, the galleon presented an overall length of 3.5 times the maximum breadth to make it slightly faster, a feature ideal in combat. Additionally, the galleon was characterized by having a taller stern and a shorter forecastle in comparison to the carrack, giving its classical crescent shape. This was necessary since boarding was still a common warfare tactic during this period, and the stern castle was used as a defensive structure. It is important to mention here that the line that divides both designs can be very blurry, or sometimes ships had different purposes during its service. It is not uncommon to see galleons that, after serving in battle, became commercial ships, or given the circumstances, carracks were armed to be sent to battle due to the lack of appropriate warships. Regarding these differences in rigging, configuration, or upper structures, both types were more common than expected. Historical sources and archaeological evidence have allowed us to make estimations on the design of the Iberian hull. As Ormachea, among other researchers, have pointed out, the stem was usually determined by approximately a quarter of a circumference, and in the case of galleons, due to the longer size, it was slightly larger than a quarter. Similarly, to design the master frame and therefore the rest of the hull, a single arc was traced to give the rounded characteristic shape of the Iberian ship. The location of the center of these arcs were again based on the nature of the ship. The center was lower on galleons to provide water space for the gun deck, while for the carracks was higher in order to make the ship more stable. It is worth mentioning, though, that Iberian ships can also present multiple arcs design, especially in the Basque region, due to the close English influence. Another remarkable way to define the Iberian tradition is through the constructive features pointed out by Thomas Ortling. Since these 11 traits are a more specialized topic, I wouldn't like to extend more than necessary. I would like just to mention that these characteristics, like the dovetail scarves, the combination of tree nails and nails, the natural ground keel knee, the single piece heel knee, here that we can see here, the extended keelson for a masthead, and the buttresses and bilge stringers, among other features, are resourceful markers to identify the Iberian origin on shipwrecks. Of course, besides personal belongings of the crew and dendrochronological analysis. Thus, I would like to propose another way to define the Iberian tradition. The main focus of the present methodology is to propose a new approach to compare and determine the Iberian tradition. It focuses on the calculation of the coefficients of form to, first, determine the parameters in which the Iberian style ranges. Secondly, to establish the model value and variance of the Iberian cases in order to understand the relationship of standardization versus agency among the Iberian shipwrights. Finally, I would like to use this data and compare it with other European traditions of the same period to evaluate the similarities or differences between them. For the project, 10 study cases were selected. The Nuestra Señora de los Mártires, also known as the Pepper Wreck, the San Juan de Pasajes, the Western Lech Reef Wreck, the San Martín, the Nuestra Señora de la Consolação, the Statland Bay Wreck, the Angra D, the Emmanuel Point Wreck, Nuestra Señora del Rosario, and finally the San Diego, a Manila galleon. Currently, 4 of these cases have been analyzed already. In the present slide, we can observe the 3D model of the proposed, sorry about that. We can see the proposed hull reconstruction of the Western Lech Reef Wreck. This site was originally researched by Dr. Piotr Bojakowski during his doctoral dissertation at Texas A&M University. In the last year, we worked together using his archaeological evidence to create a 3D model of how the hull might have looked like, based on the keel and the framing remains recorded by Dr. Bojakowski. In this next slide, we can appreciate the lines plan of the ships that have been analyzed already for this project. The first study case is the Western Lech Reef Wreck that I showed a moment ago. The results have been published already by the author along Dr. Bojakowski on the last year. The second one is the India-Portuguese now, Nuestra Señora de los Mártires, who was originally reconstructed hypothetically by Philip Castro. But while recreated in 3D, it was calculated by the software that the lower section of the stern of the ship required adjustments to acquire the firmness necessary to make it feasible. The third one is the proposed reconstruction of the Manila galleon San Diego, published originally by Jean-Paul Desroches, Gabriel Casal, and Frank Godio. Finally, the whaler found in Red Bay, Canada, the San Juan de Pasajes, which lines plan was originally designed by Brad Lowell. Now, the coefficients of form are a very simple but effective way to understand, define, and calculate the shape of the underwater portion of the hull in a quantitative way. For this reason, it has become a very common practice in naval engineering while designing ships. The four main coefficients are the midship coefficient, the water plane coefficient, the block coefficient, and the prismatic coefficient. As seen in the picture, the midship coefficient is the proportion of the midship section in comparison with an area of the same length and height. This coefficient is useful to calculate the cargo capacity of a vessel, which means higher values are associated with larger cargo holds and vice versa. Similarly, the water plane coefficient follows the same concept but with the shape of the hull and the waterline. This coefficient can provide an insight about the stability of the ship. The larger the value, the more stable the ship will be. The block coefficient is unlike the midship one, but taking into consideration the three dimensions. It's the proportion between the submerged hull and a block that contains it. Finally, the prismatic coefficient is similar to the block one, but it uses a prism shaped like the midship section instead of a block. These last two coefficients are useful to determine if a hull is prone to be faster. Low values are associated with faster ships or more power-efficient ships, while higher values indicates that the ship requires more energy or are slightly slower. In the table, we can observe the results for the four study cases already analyzed. The midship coefficient ranges from 0.89 to 0.95. The water plane coefficients from 0.7 to 0.92. The block coefficient from 0.48 to 0.66. And finally, the prismatic coefficient from 0.53 to 0.7. Now, having explained briefly the coefficients of form and their utility, I would like to define some concepts required for the current project: the model value and the standard deviation. In statistics, the model value is the average value or measurement from a population of samples. It can be calculated from the median, but preferably from the mean of all the values in the dataset. On the other hand, the standard deviation is the degree into which how much the sample cases can vary from that average. In the present picture, these concepts are better explained. These 9 gentlemen of different heights are shown one next to the other, with a line representing the model value for the height, and additionally, a white line on each person represents the deviation from each case. After explaining these concepts needed for the research, now I would like to show you the results we have obtained so far. Regarding the midship coefficient, the model value is 0.917875, with a standard deviation of 0.0225, which shows a very, very low degree of variation for this variable. On the other hand, the water plane coefficient has a model value of 0.811375 with a standard deviation of 0.0946. Again, a very low degree of variation. In this next slide, we can see the other results. The block coefficient presents a model value of 0.57295 with a standard deviation of 0.07429. And finally, regarding the prismatic coefficient, the model value is 0.62345 with a deviation of 0.0696. Both cases presenting very low variation again. The results displayed in the previous slides are also useful to determine a linear model of the variant design. In statistics, linear models are formulas that describe the outcome of a response variable based on a function of one or more predictor variables. Therefore, it's a useful way to predict data. For example, in Francis Galton's 1886 experiment, he used this concept to predict the height of a person based on several factors like their parents' height. Another example to illustrate the use of linear models is to predict the amount of gas employed for heating during the winter based on the outside temperature. The structure of a linear model is very simple. Y is the response variable that depends on a predictor variable x that is multiplied by a coefficient m and finally adds the intercept value p. In the present research, I am utilizing a linear model to determine the parameters in which the variant hole was conceived. Also, I selected the midship coefficient as the response variable since it's directly associated with the master frame, the piece that determines the overall shape of the hole. In the lower section of the slide, we can observe the calculation based on the 4 study cases already analyzed. The midship coefficient is going to be the result of the other coefficients affected by these values seen on the screen. Based on these preliminary results, it can be concluded so far that the standard deviation for the 4 coefficients is minimal. 2% for the midship, 9% for the water plane, 7% for the block, and also 7% for the prismatic coefficient. So what can I do with this data then? What are the repercussions that are relevant to archaeology? The anthropological interpretations obtained from this are, first, little variation in hole design among the Iberian shipwrights. Despite not counting with formal training or formation, the Iberian ship design was culturally well established with little space for individual agency. In this topic, the shipbuilding tradition was a very structural process. Moreover, the linear models serve as the basis for the classic Iberian ship conception, and it can be useful for future research, especially while complementing current work and contributions by diverse scholars. Naturally, as I mentioned before, this is an ongoing project that is still pending analysis from the remaining case studies to improve the upcoming results. Once all the Iberian examples are analyzed, the data obtained from them, especially the linear model, will be compared to non-Iberian ships like the Mary Rose and the Vasa to calculate how well it will fit, determine similarities or differences. If the formula works, or at least is a close result, with those cases, we could determine that the similarities between different traditions, if we could determine a lot of similarity between different traditions. If not, it will show that there are more differences than expected among different ships. Regardless of the result, I believe that this research topic is an ideal example to show the relevance of statistics and even data science in human and soil sciences to improve the quality of our results. I would like to thank you so much for your time and interest in this small case that I hope it can enlighten us a little bit more. Thank you.